Hello there and welcome to another Origin screencast. In this episode we're going to look at how to create a test program flow with Origin, and like the patterns created with Origin, this will be able to retarget to a range of different test platforms, all from a single source. Okay, so I'm continuing here from the application from episode 2. Now one of the things I'm going to check first of all is to make sure I've got the latest version of the Origin Testers plugin, because we're going to use that heavily today. So I'm currently running Origin Testers 0.5.2 and that has been updated since then. So we'll say bundle update Origin Testers. Okay, there we go, that's installed the latest version. We could just confirm that's what we're looking at now. Yep, that looks good. So if we go to our source code, the first thing to do here is to create a program directory. By convention, that's where all the test program source files should live in Origin. So make one called program. And then we'll create a file in here called, let's call it sort1.ruby. This is going to be our sort1 flow file. Okay, so if we open up this flow file here, we're going to create a few tests initially to get it all working. So to create a test, we just write in here test and then pass in the name of it. So I'll just say test A. And then you can pass in things like the bin number, a soft bin number if you like, and a test number. In fact, I think it's just number for the test number. Let's do a couple of tests. We'll do a test B here. Just give that a slightly different soft bin. And in the end we can pass out to a bin 1. Okay, so let's try and generate that flow and see what happens. Okay, so currently I am running, let's check what environment we're using here. We're using the J750 environment, so if we say origin P for program generator, origin P and then point to that file, Origin will then generate that. Here I'm actually getting a warning that my workspace has got local modifications. This means that Origin is running in production mode. To change that, I'm just going to change the mode to debug mode. Now we can run that. Okay, so that generated that file there. If we can have a quick look at it. Okay, so here we have an NGXL flow file here that's been generated. I've got my two tests here, A and B. There's my test number, my bin, my soft bin, and so on. And then at the end it's going to set the device to a 1 if it gets that far. Now, the key thing here is that this can now regenerate to any other target as well. So we can say let's instead generate it for the 93K. We can have a look at that. It's generated a few files here for the 93K for the flow. Okay, so this is the 93K file here. Very different format than the Teradyne. The main crux of the flow is down here. So we can see here that we've got we're running test A there. If it fails, again we're going to bin out to these bin number 100 and so on, hard bin 3, and then at the very end here we're going to set it to bin 1 if it gets that far. Okay, so it looks like that's initially working. Now this program generator is provided by the Origin Testers plugin, and if I just look at the if I just run the Origin command here, I can see the sub-commands I've got available. One of them is this one here from Origin Testers runs. This will run the last test program generated for the current target. So what that means is basically we can run that flow in the console here to check that it works. So we can say Origin Testers run, and it's asking me I must supply the name of the flow to execute. So what happens is every time I run a generation, it's creating a program model in the background here. That program model can contain multiple different flows. This one only has one, but it's still making me put in the name of it. So we'll just tell it they want to run the sort1 flow. Okay, so it ran the flow there, so we can see that these tests passed here, and then we binned out to a bin 1. Now what if test A had failed? Well, we can simulate that by saying run that flow, we say -- failed and pass in the ID of the test. So let's pretend that T1 failed here. Sorry, that's the wrong option. So I've forgotten the option here. What would you do if that ever happened to you? So what you do is you say origin testers run -h, and actually the keyword here I was looking for was fail, so we can run with -fail. So now it's simulating what would happen if that test failed. If that test failed, it would then bin out to a bin 3 and soft bin 100. Now that's not too exciting, but this will get more exciting as the video progresses. So if we go back to our flow now, what else can we do with that? Well, one of the first things we can do is we can start to make conditional tests here. So let's say we had another test, test C, but we only wanted to run that if test B was to fail. So we'd say test C. I'll just leave out the bin number and stuff for now for speed. So test C, and then we want to run this only if failed, and it's going to be test B. Now we could say, might want to actually say here test B. The problem with that is though that it would be quite illegal here to do something like this and run test B twice. In that case, if we do something like this, which test B are we really referring to? So anytime you're setting up a dependency between tests like this, you have to give this an ID. And Origin will enforce that the ID is unique within the flow. And this just so there's no ambiguity about what we're actually talking about here. So we'll just call this, test. Just give an ID of test 1. So we'll say if failed test 1, then we can go and generate that. So it's going to be origin P. We'll just start running that in the whole directory now. So this is ran on the Teradyne again, so we can have a look at that. Okay, so now we can see that it's generated some flow logic in here, where it's said basically, it's saying here if this test fails, then we don't bin out now, but instead we're setting this flag here, which Origin has generated, and then this test here will only run if that flag is true. Now, this is I don't know if you've used IGXL before, this is the kind of thing that tends to be very hard to peer review, because it's not obvious when you're reading the flow like this what's actually going on. So the idea here is that really we're defining our flow logic in a much higher level and more abstract way, and then we're relying on the compiler or the generator to generate battle tested and working flow logic that will be used at runtime. By the way, this ID here is just generating a unique ID. So this is so that this flow can be then built into a bigger test program with other flows, which may or may not have used Origin to generate themselves. If they had, then there's always a chance that they could have used a test ID called test1 or something. So Origin just appends this unique ID to this flow to guarantee that there's never any naming collision there. Now, of course, this will work in the console now if we try and run that. So we can run it first of all. We don't get test C running this time because test B didn't fail. But if we make test B fail, the ID is test1, then we can see that this time, okay, that test failed, but the flow did not bin out, and instead it went on to run test C, and that's doing exactly what we want it to do. Okay, what's next? So a very common thing in flow logic is to have tests that only run under a certain job. So it might be the case where this flow is actually executed at both sort 1 and sort 2, say, and then I've got some tests here that we only want to run at sort 1 and some tests that we only want to run at sort 2. So we can say a test, let's say this is going to be a P1 test, probe 1 test 1, and we're going to say if that's going to be if the job is probe 1, we want to run that test. And let's say we've got a probe 2 test 1, and that's going to be if the job is going to be probe 2. Now that would do exactly what we expect there. That would only execute if that job enable had been set to high. More commonly, you will probably have a range of tests. So let's say we had, probe 1, test 2 and 3, and probe 2, test 1, 2 and 3. Sorry. Now this would work fine, but it's a little more elegant in this case if we just say, put this in a block here. So if job is P1, and then we want to do these. and then down here we can see if the job is P2. Now basically all of the flags that I'm showing today, including that if failed that I did up above there, also support this block format as well. So basically you can either do it in line here for a single test, or you can do it in a block format like this to wrap a range of tests. So we can go and check this out, make sure it works. So we do have to regenerate the program to update the model. Probably in the future we will make it smart enough to know if you've updated the source, and it will automatically regenerate the model. Right now you have to generate the program again to update the model, but now we can run it. So now it's telling me that the flow now contains job-based conditions and no current job has been given, so it can't run because having no job is not really a valid runtime condition anymore for this flow. So say that the job is going to be P1, probe 1. So this time we ran, and there's the probe 1 tests all executed. If we run under job probe 2, then as you can imagine, there's the probe 2 test get executed instead. So that's all working as we'd expect. Now of course if we do go and have a look at the flow, this will all be generating, so this will be generating the correct flow logic in the background. So here we can see that these, in the Teradyne example, these have the job column, which is that guy there. It's a tab delimited file, so it's quite hard to see how it lines up, but basically this is the job column here, probe 1 and probe 2. Okay, so let's up the ante a little bit and do something a bit more complicated. Let's say we now want to run this P3 test only if both of these failed, and that's all going to be nested within this job qualifier here. So we'll give these both an ID, so we'll call this say P11, and this is going to be P12, and then if we want to run this, if both of these failed, we would say if all failed, and then pass in an array containing the IDs that we care about, so it's P11 and P12. Alternatively, let's say we want to run this probe 2 test 3 if either of these failed. Or let's say actually just to show that if either of them passed. So I've showed the failed condition, but you can do it if passed as well, which is for the inverse logic. So let's just say the ID of this one is going to be P21 and P22, and this is going to be if any passed, and then we'll say P21 or P22. Okay, so we'll go back to our flow here, regenerate it, and then run it. So we'll actually change this to the probe 1 job first of all. So here we ran our probe 1 tests, and test 1 and test 2 ran, but test 3 didn't run. So the logic we said to that was that if all of these failed, then run test 3. So we can say if fail P11, then nothing happens. But if we run and fail both of these now, then we can see that now test 3 kicks in. And if test 3 itself was to fail, then we should actually see it binning out. Yep, so in that case it would bin out. No bins assigned here because I didn't add it in the flow sheet, but that would be whatever bin was assigned to test 3. If we run with job P2, the flow logic we applied to that was if any of these passed, then test 3 should run. So these both passed in this case, so test 3 went ahead and ran. We can say if failed P21, then that failed, but that didn't really affect what happens here. That one still passed, so P3 goes ahead, test 3 goes ahead rather, and we can say if failed that one, and now we see that test 3 goes away. Now such logic might not make sense, but hopefully you'll get an idea that you can start to build up some fairly complex flow logic here. And in fact, if we have a look at the IGXL file, now we can see that in the IGXL file it's starting to build up some fairly complex flow logic here to implement this. And again, this is the kind of thing that when you're looking at this and trying to peer review it, it's not easy. And honestly, this has been quite a source of some bugs for us over the years. So we're finding it much easier now to define all this at origin level, but it's easy to review, it's easy to test out in the console here, and we're relying on the fact that the origin compiler is becoming more and more solid over time, such that we can fully trust what it's generating here in the background. And of course, I haven't run the 93K for a while, so let's go ahead and run that as well, just to make sure that it's doing something sensible there. Okay, let's have a look at this. Now the 93K does tend to be a little bit easier to read anyway, especially if you were to open this up in Smart Test. But here, again, the logic here will all be valid. You can see it's setting up runtime flags here in order to implement the logic that we asked for. So that all looks good. Okay, so another example that we could do, perhaps a more real life case, would be to implement some speed binning logic. So you can create a group of tests like this, and you give the group a name. So let's just say this is the 100 megahertz tests, and then let's say we'll have 200 megahertz tests down here. Well, that's the wrong way around, isn't it? So we'll run the fast ones first, and the idea would be that if any of these tests failed in here, then we go on and run the 100 megahertz tests instead. So we'll add some tests in this group here. So this will be, I think in Ruby you can't start a symbol with a number, so let's just say test 200, 1, 2 and 3, and do the same down here. Now, we only want these tests to execute if these fail, so as with the test, we need to give this group an ID. So we'll just say this is just going to be G200. And then here we can just say this is going to be if failed, G200. Then you execute these ones. Then if that passes, it will then go through to bin 1. If any of these fail, then that will just bin out. That seems to be, I think that's all we need. So let's try that in the console. So this is the beauty of it. I was actually not sure that if that was the right logic, so the easy way to check is just to go and see if it works on the console. So let's go and generate it. You can generate it for any tester, so I'll just run the 93K again to update the model. Okay, so let's run our program. So now we can see that the test 200 tests all passed, and then we've got a bin 1. Let's simulate one of those failing. So let's see, let's imagine the one in the middle failed, so that'll be T6 here. So if that one failed, then the test 100 tests kicked in, but it's still a bin 1 actually, so that's what I was thinking we should have added before. So what we'd normally do here would be that if it ran to the full spec test, it would pass out to a bin 1. If it had to drop down to these tests, we'd probably want to bin it out to something else. So let's say pass to a bin 2, if passed, G100. Now I need to give this an ID here as well, in that case. Okay, so we're saying that these are going to run first, and then if these failed, these are going to run, and then if these ran and passed, then we're going to bin out to bin 2, otherwise it'll bin out to whatever bin these were. So we'll just put a bin number here to confirm that, so let's just say 0 bin 5. Okay, and then back to our console, regenerate. So run it as we ran it last time. So this time our 200 megahertz test failed, then the 100 megahertz test kicked in, and then it binned out to a pass, but this time it was assigned bin 2. We'll just confirm again that if we take that fail away, if it runs the 200 megahertz test, now it's going to be a bin 1. So again, if that was to fail, and then if we have one of these 100 megahertz tests fail, then what happens? So now it passes to bin 1. So that's really showing that there's a genuine issue here with the flow logic, so let's go and see why that was. So what's actually happened here is that anytime you make an if passed or an if failed condition on a given test, Origin will automatically set that test to continue on fail, because it's kind of implied by the fact that later on in the flow you're expecting to handle the case where it could have passed or failed, so we don't want to bin out. So because I've said here this is if passed, that set of tests, Origin has said, okay, well if that fails, I'm just going to continue on down, because I'm going to handle the if failed condition down here. Actually, what I really wanted to say was that if these ran, then do that. So if it ran, we run this test here. That will not add the continue on fail flag to that group of tests. So let's try that now. So I just need to regenerate it first. So that looks better, but still not quite right. It has binned out now, but it hasn't applied the bin 5, and for some reason we're getting 2 failure lines here. So I think this is basically found a bug. This is quite a new feature. Actually, it's kind of hot off the press that I'm just demoing here today. We don't actually run this in production today. So yeah, so I think I found a bug here. I'm not going to solve it on camera in the interests of going ahead with the demo, but that will I will raise a ticket for that and get that fixed immediately once I finish here. But hopefully that gives you the idea. What should have happened there is that should have binned out to a bin 5. And the offline runner has kind of done its job here, because basically if it doesn't work quite right here offline, it's also not going to work quite right in the test program compilers. So that would have generated the same flaw in the real life program. So both good and bad. Slightly embarrassing in a live video, but what can I do at this point? One other thing to mention is that here I've done a job condition. You can also do enable word conditions, so we can say, let's say we had a bitmap test in here that we only wanted to run if the user had specifically enabled that. So let's just say if enable bitmap. Then we'll do another test here. That's going to be some bitmap test. So this just works exactly the same way as the job. They can be fully nested. You can also nest multiple enable words here as deep as you like. Same goes for any of these kind of if failed conditions. You can nest them and that will all work as you would expect. So if we just quickly check what that's done, regenerate the flow here. I'll take off these fail flags for now. So here we can see we're back to our 200 MHz test passing, getting our bin 1. We can test that enable word being present, which we call bitmap. And we can see okay, so in this case the bitmap was actually under the P1 tests, so we'll go back to the probe 1 tests here. So now we get a bitmap test running. If we take that away, then it doesn't run. So for the most part this is all working and is confirming that our flow logic is what we want it to do. Now this is obviously a fairly abstract example here, just using tests called 1, 2 and 3 and so on. In real life what you'd really want to be doing here is accessing your model, your device model. So of course you've got full access to that here. Probably one of the interesting things we could do here in the demo is the DUT model that I've got here had got 2 A to Ds. So we could say DUT dot A to Ds dot each to A to D, and then basically for each A to D instance on this DUT we will generate an A to D test. So actually we'll just grab the index here as well. So you have the concept of kind of compile time or generate time logic, which is what this is, and then runtime logic, which is what I've been showing up until now. So this will basically this will be evaluated at the point where I'm generating the program, and this is obviously going to execute later on when it comes to runtime. So let's just say we'll add a test here. It's going to be called, let's just say A to D ramp test, and then the A to D ID. So I'll just say A to D ramp test 1, A to D ramp test 0, and so on. So if we go and run that, so now we can see that we get 2 of these because this model has got 2 A to D instances. If we ran that in a different model with 3 A to D instances or whatever, then that would obviously update appropriately. So this is the real benefit of this, that we can start to build, you know, fully dynamic programs that customize to the target model. Okay, one of the last things I would like to show in this video is that we can also use the concept of subflows. So if you watched the video on the compiler, you would have seen that we can use sub templates in a compiler. Well, exactly the same thing can be done here. So let's just say this is actually going to be the A to D tests. A to D tests .rb. So again, by convention, any subflows should start with the name underscore, and that will stop Origin trying to execute that if we just tell it to generate this whole directory. So if we open that up here, the syntax is exactly the same as before. Any options that we pass in when we call this will be available here as well. So we can we can customize it at the time that we call it. So we'll just take actually this A to D's out of here, we'll put them in here, and then here we just want to say basically import A to D tests, like that. So if we go and generate that, make sure it works okay. Then we can see that works as before. As I mentioned, we can pass in the options, so perhaps another way of implementing this would be, let's say we pass in that instances argument here, which would be basically .a2ds.size, and then rather than .a2ds here, we would just say options instances will be times . Okay, so if we pass in 1 instances or 2 instances, that's going to generate the same sort of thing. So we can try that there. That looks good. So just to confirm this is working, let's just say we passed in 4 here. Regenerate. So now we can see we're getting our 4 instances there. What's really nice about this is you can basically make these reusable flow sections like this. And what's nice is that you can wrap these in conditions from the place we actually call it. So here it doesn't apply any conditions at all. Basically these tests will always execute as implemented in this subflow here. But let's say at the point we're calling it here, we only want to really run these at sort 2. So let's just say if the job is probe 2, then we want to do that, and that should work correctly. So if we run here, now we're running probe 1, we don't get our A to D tests. If we run probe 2, then we do get them. So this is a very powerful concept, and in some of our production flows today, we may have maybe 20 or 30 different flow components, and then we have got a number of top level flows for sort 1, sort 2, final test, QA gate, where we call all these subflows, and then we pass in parameters to apply guard bands or to apply conditional execution. So you can use these to build extremely complex flows, but because you're doing it in a kind of a modular way, it's much easier to keep control of them than if you're doing it via some other means. Now the final thing I wanted to show was that because we're using this, we're building up this program model in the background, one of the applications of that, as I've shown today, is you can build this offline runner, which Origin provides for you. But we can also use that for many different things, and one of them is to build documentation of your flow. So if we go to the Origin web page, and if we go to the Doc Helpers plugin, we'll see that one of the helpers that it provides is this test program flow plugin here, and it's showing me here how to integrate that. So what I'll do is I'll copy that, and let's see, my application file here. I'm just going to paste this in. So again, this was shown in another video, video 2 I think, a similar thing for generating model documentation. But this is a fact here that's up here. So this is a callback to generate that model documentation. So I don't have to redefine this method actually. So I want to now build some test program flow documents as well. So the program name I ran was called sort1. And it's going to be the sort1 flow. Which target am I running here? So I need to tell it the target. So origin T will show what the current target is called here. So it's just called default, so that's fine. Okay, that should actually be all there is to it. I think it does advise me in the integration notes for that helper to also add it to the navigation bar. So this is saying the tab is called flows. Okay, so that's just updated my website's navigation bar to point to this flow documentation. So if we now go and generate the website for this application, so origin web compile. Okay, so the problem there was, I guess, what's the problem there? Okay, so first I have to build the program, so it's sort1. Sorry. Okay, so I'm getting the feedback here that I've got that same problem I had online here that I haven't given it the job to know what to generate, so hopefully there'll be an example of that here. Okay, so we need to supply a context option. Okay, third time lucky. Okay, so that's built, and if we want to have a look at it, so here's my documentation here. I've got this flows tab here, and we can click on that sort1 flow. So here it's showing me basically what my flow is, test A, B and C. So this is applying the context that I supplied there, so basically it's just supplying the probe1 enable word. Every other test is assumed to pass, and this is what my flow does. I do also have this flow view here, which shows more of the flow logic nesting. So we can see, for example, if bitmap's enabled, then we're going to get this additional test here. We've got our 200 megahertz tests here, and so on. So this is browsable documentation of the flow for people to come and have a look at. It would be more useful if these tests had descriptions of what they did. The way to add that is within the flow file itself. So we can say here, we can add Ruby comments above, so this test will do something. Now you can use Markdown here in your comments, so you can say things like some bullets about this test. So if we go there and regenerate our web page again, so we can go to that test. Now we're seeing that we're getting some documentation that tells us what that test does. In the next video I'm going to show you how to actually create test instances or test methods to go with this, and once you do that we'll start to fill in with limit information and things like that in here. But for now, this is just showing you the flow order or descriptions, but you're basically getting this for free is the main point to take away. And if you've got any other preferred formats, then it's not too difficult really to take that model that we have in the background here and use that to generate a different view of the flow however you want to consume it for documentation purposes. Okay, so that's it. So the idea is that in a production scenario, you would basically document these as you're creating them, and then that's your documentation done and for free. So in the next video, we'll expand this a little bit to show how you would then create the test instances, the patterns, and so on to go with this, and that will be the subject of the next video. Okay, thanks for now. Goodbye.